Well, oh, let me turn on the lights. There's some good news and some bad news about my progress with this. The good news is that I figured out how to triangulate things. So that's cool. The bad news is that um I forgot what the bad news is. Oh, dealing with holes is annoying. Anything that has a hole in it. So I'm gonna need to write some more detailed code on that'll help me to debug that. Like more targeted. Now this one, 86912. Okay, so this is only 12 points. And none of them are repeated. I guess this makes sense. Okay, so there's 12 points here, and then the indices will be potentially longer than that. Okay, that makes sense. But I'm gonna have to write code to do this with and without triangulation. Which will be a little annoying, but gotta do it. So firstly, I'm gonna move this down. The attributes array, this way that I can get the triangulation. Which I guess I'll need either way. I should just get the vertices and the indices both no matter what. Then I should have a flag here, like if use triangulation, something like that. Then I'm going to do something, otherwise I won't. Well, if I'm using this triangulation, this length, the number of... Hey, Aquabeam, what's going on? The number of vertices passed into this buffer, that should be the number of vertices in the object. This would be object at 0.data at points. That shape at 0. Like this. And here, if I'm not using triangulation, then I have to do this once for each vertex. So vertices that shape at 0. Like that. And right now I'll just focus... Oh no, I'll just move on to the next thing. This will be the same no matter what. These will be the same no matter what. Passing the object data into the attributes, this is only if I'm not triangulating. So I should go there. If I am triangulating... Oh wait. If I am triangulating, I should do this. If I'm not triangulating, it's just the vertices. I hope. Then I can get the vertices here, the index vertex buffer here, index buffer here. Great, I think that's all I need. So then if I just use triangulation into true, maybe. Okay, I guess that worked. I set that to false. Close, I guess. Oh, in this case, I don't need the index buffer. So I guess I can move this up too. Here, the index buffer, if I'm using a triangulation, then I'll set this to that. Otherwise I can set it to none. Then I will only want to release it if that's not none. That's when I'll have to release that. Cool, so let's try this again. Okay, that works. I forgot if this is triangulating or not. So it works if I do not triangulate. If I do triangulate, then that works too. Okay. Now I happen to know that using triangulation doesn't work if the shape has multiple contours. And when I say contours, I mean the definition from this library. So I have to figure that out somehow. So I feel like I can factor this out a lot more. If I just have like something like attribute length. Let's set this to this. And then otherwise I can set it to the vertices shape 0. So these should both work. So it works that way. Then if I set this to false, that works too. So this can be factored out. Wait. I guess since I'm setting the attributes here, that can't exactly be factored, or can it? No, I guess not, because I'm writing the attributes here. Dang. Which is too... I want so bad to just take this out. Like this. I guess I can just have another if-else beneath it. Oh well. Sort of ugly. Oh yeah, that's right. Actually, I could... I just said attribute data or something like that. And here it'd be this. And here it'd be this. And now I can just set the attribute, set this to attribute data. Great, so that works with false. If I use triangulation, also works. Also, what's my shortcut here? It's the same thing. Cool. Great, so now I guess it's gonna come down to figuring out why this doesn't work if I have holes. So this shape has a hole now. If I do it with triangulation, this won't work. If I do it without triangulation, then it does work. So I've got to figure out why that's happening. So I'm going to set a triangulation to false here. And then just print out the data. And this is going to be the list of vertices that's used to triangulate this. And I should print after it or something. Okay, that's fine. I think I'll open a new window here. Set that to true, then when I get these indices, I'm gonna break there and then try to compare them to the vertices from the non-triangulated version. And see what's wrong with that, because it's not totally clear to me. So now I can run... I can index the list of mobject vertices with the index array. So I can say mobject, I say print attribute data, that's the mobject vertices. I can index this at indices. Okay, and these, I want these to be the same as these, but they're not. And I can probably see where they're not. So I guess that's at the end somewhere. And nope, they actually look remarkably similar. No, they're not exactly the same, actually. Yeah, there's some differences. This is the same, this is the same, this is the same. This is 220, but this isn't. 1, -1, 0. So how did this get off? I guess I already knew in some sense that these wouldn't be right, because otherwise it would have worked the first time. Indices as type NP int32, that's correct. It'll have to do with whatever happens when I do begin contour and end contour. I wonder if the lengths are even the same. Let me run that again. Okay, get the shape of that, 48. Didn't mean for that to get destroyed, but whatever. I can get the length of this. And I just flip that flag. The length of this, that's also 48. So it seems like if it's anything, it'd probably be the order of those vertices. Why is it so quiet? Weird. I can see if this is getting printed, the begin callback. You should probably check the end callback too at some point. And by some point, I mean now. They are called. Let's see. And this is the end callback. I'm gonna see. How many times these are called. So, wait, what in the world? Polygon begin, polygon end. Then the begin callback is called. And then the end callback is called. Interesting. Okay, so I guess it doesn't do the contour until after the polygon is finished, which I guess makes sense. That also seems like it should mean that indices should work. Maybe I just need a simpler shape to start with. Although the shape is pretty simple. Yeah, I think I just have to compare when the two arrays start being different. Okay, so make sure this works again. Okay, that's the shape of the hole. Works without triangulation. Let's turn on triangulation. That breaks it. Also, the begin still appears. Yeah, I guess I have to print these or something. So let me do that. And they didn't get printed. I think it's too loud, actually. Life's tough. Okay, print that. Not the shape, oh my goodness. Okay, this... I'm gonna try to write to a file. So what's the current goal? The current goal is to write a fill shader again. Because the fill shader I wrote, it's actually not that bad, but it'll require some complications for mobjects, which have submobjects, which have lots of different colors. Basically that thing that Daryl Golden pointed out where it won't fade in normally. And the reason for that I figured out is because all of the mobjects would have to have the same style, at least in the same texture, for that to work. So I could split it into more textures and more render calls, but I think at that point, the work is probably not worth it anymore. And so I'm basically rewriting the fill shaders. Starting from scratch on the fill shaders. But the hardest part is mostly just getting this library to do what I want it to do. Yeah, it's not actually being terribly difficult to triangulate things. I mean, you saw a few shapes that were triangulated already. But getting it to use indices and getting it to curve the Bezier curves correctly, or draw those curves, that's a little harder. Make a triangulation.text. Doing x's. Okay, then I want to compare these. No triangulation.text and then triangulation.text. Okay, and where did this go wrong? I should vim lift this. Really early, actually. -110, -110. Just leaves this out. Like the very end is pretty similar. So strange. Because I've written this so that whenever a vertex is emitted, it's appending the index of that vertex. So why would this be any different than the non-triangulated version? The vertex at 1. -220. This, it's right here, this -110. So what I guess I have to do is track down when that gets emitted. Well, the object is here. So whenever something's emitted, I could triangulated vertex. And this should be... Oh wait. I'll just... All of these I'll have to add. So triangulated vertices, mp.empty. So I do that, set it to empty here. And here I'll append the triangulated one. And what I'll append is object or mob.data at 0. No, mob at 0 dot data at points indexed at this index. And these should always be the same. Oh, index at vertex at 1. Yeah. And I need the non-local here. Do that. Great. Okay, so now I should be able to just pause here and look at all of these. Or maybe this isn't where I want to pause. I already know it's gonna happen. So let me not do that and not return this. And here I'll just print the vertices. What do they do? Like numpy dot append or something. And I want you to do that on axis 1. And then I'll do a breakpoint. Okay, so hopefully this will print both vertex lists as each one is emitted. Wait, what did it print just there? This. Line 57. Oh, it skipped all of that. No, wait, what? Vectorized object rendering 57. It broke here. Oh, it hit this one. Does that mean it never hit the vertex callback? Because that makes no sense. Why would it not be breaking here? Triangulate object. It's taking object at 0, which means this actually shouldn't be at 0. But why is this not breaking? Will it break here? Yes, it will. I wonder if it'll break like at the top of that callback. Okay, it'll do that. Weird. And it shows that it is working at that point. Oh, but I can't quit from here. That's annoying. Yeah, okay, so getting both a vertex here and a triangulated vertex here. I want to make sure these are always equal. So I have to say if not vertices that shape vertices indexed at -1, triangulated vertices indexed at -1. If these aren't pretty much the same, this is when I want to do a breakpoint. Which I think will crash it or something. But I still want to do a breakpoint there. Okay, so now we print the vertices for the triangulated. Man, so much stuff. What in the world? Okay, so here. So what had to happen for that to happen? Vertex at 0. I appended vertex at 0 to vertices. I appended vertex at 1 to indices. And that second part is supposed to be the index of the vertex. So I look at vertex. -1, 1, 1 at 0. -1, 1, 0, and it has index 11. Okay, so I print object at index 11. It just isn't -1, 1, 0. It's half of that. Well, no, it's double that. And why would that happen? Is it this? When it combines vertices? -1, 1, -1, -1, 0, -1. There are a few places where it looks like it might be doing half. I think this is coming from the combine callback, like it has to, because here, with each point, I'm passing its index. Non-negotiable. So what I think is happening is in one of these places, probably in the combine callback, it wants you to do a weighted sum or something like that. And that isn't working. Just to test this, I'm gonna print combining. Just something to see if the combine callback is being called. Oh yeah, this thing's... So let's print combining, and here I won't break. I'll just print index mismatch or something. Okay, and that was a ton of freaking... Wait, I didn't want to print the array. Where's the array getting printed? There, I don't need that. Well, it does look like combining might have something to do with it, but what I want to do is triangulate once and then crash. I don't want to do it a bunch of times. Okay, so that should have been one triangulation. And I do see that there's not a... The mismatches are preceded by these combining things. So maybe it's fair to say there's something going wrong with this. Oh, this is a pretty weird function. Okay. I'm just gonna break here. It's pretty complicated what this combining function even is supposed to do. But basically it's supposed to be taking a linear combination of a bunch of vertices and making those into a new vertex. Which has a little bit of a difficulty in that whatever new vertex is created from the weighted sum won't have an index because it's a new vertex. So I print neighbors. Okay. So there's a point at 11 and a point at 0. So basically the curve is being closed here. I should have kept on the terminal. Way too much stuff printed now. The first mismatch was -1, 1, 0. Which is half of this. If I look at the neighbor weights, it is taking half of these. It's taking half of each one. What am I even doing? For neighbor and neighbor, if the vertex is close to neighbor at 0. What's the vertex? And it's returning neighbors at 0. Which looks right. Yeah, -2, 2, 0. But the vertex is close to neighbor. It's right. It's gonna return -2, 2, 0 with index 11. Wait, look at that. Can I print the object? Guess not. Here I'm gonna print all of these. Vertices at -1. Triangulated vertices, -1. And indices at -1. I want to print the object too. Wish I had the object here. I guess I could just do non-local mob. No, I shouldn't need that as long as I don't edit it. But I'm sure it won't work because that's life. Okay, so if I run that... Oh man. Well, I guess I went eventually. Way too long for my taste. Okay, so don't break there. I might have to do it again in the future. Okay. Okay, so a few places where this mismatched. I want to find, like, the first one, though. Let's print a new line beforehand. The first one is an instance where it's doing half of this. Where the proper one is -2, 2, 0. Which has index 11? Wait. The vertex, the one I want, is -1, 1, 0. The one I have, triangulated vertices, is double that. Oh, I think I know what I did wrong. I can't return neighbors. I can't return the neighbor. Wait, can I? Wait, yeah, I can. I totally can. I'm gonna see what... I have to print out all the combination things. Well, at least I have F strings to help a little bit. This. This. Great, so I'm gonna print that when I see a mismatch. Okay. Okay. Then I actually additionally want to see what happens if I index the object's points at that index. Oh, that's what the triangulated vertices is. Indexing the object at the index that's returned. Is there any pattern to these? The vertex I want is a divisor of the wrong one that I get. And that happens every time. Why? It has to be something with this. It has to. But doesn't this just return the vertex? Oh my gosh. Invoke to create a new vertex when the algorithm detects an intersection or wishes to merge features. The vertex is defined as a linear combination of up to 4 existing vertices, referenced by vertex data 0 through 3. The coefficients of the linear combination are given by the weights. These weights always sum to 1. Yeah. And the examples I saw, combine just returns the vertex. The difference is that I need that index too. And the vertex, I don't think has that. Let's do this. Print out the vertex, neighbors, neighbor weights. Yeah. Okay. Now this is kind of a lot. So the vertex this, the neighbors. So this has -2, 2, 0 with index 11. And here, the correct vertex is -1, 1, 0 at index 11. There are 2 vertices with index 11. How's that possible? The same with index 8. And index 5. Here, 2, -2, 0. And here, 1, -1, 0. So 8 and 5 and 2 and 11. It's being switched. Or 11, then 8, then 5. Then here again, this 11 is half of that 11. This 8 is half of that 8. This 5 is half of this 5. I'm to 2. 2 got halved as well. So there's still something I don't know about how these are being combined. But here... Okay, so the vertex, which is at index 11 in the mobject, is this. -2, 2, 0. What this must be saying when it emits a vertex like this? Does that mean from here on, index 11 should be associated with this linear combination? Like half of this? It doesn't make a ton of sense. Well, that seems to be what's going on. Because here it's taking the neighbor vertices negative 2, 2, 0 at index 11. And negative 2, 2, 0 at index 0. So this is a repetition. It's multiplying them by these scaling factors. It has to be. And then the output vertex is this. Then following that, the next time that there's something at index 11, here, it's the linear combination. But then would this be supposed to be halved again because there's a 0.5 weighting here as well? Damn it. That's really annoying. There's not really any way to figure out what this is supposed to mean. Creating a new vertex when the algorithm detects an intersection. And that vertex is defined as a linear combination of up to 4 existing vertices. So it's creating a new vertex here. Although this vertex already exists twice, it's doing it again, I guess. Yeah, this is very confusing. Like here, how can this make sense? I think what I have to do, it may not be even worth it to try to figure out what the library is doing, and instead just handle all the indexing on my own. So like look up into a hash map or something. Because it's really unclear. Maybe I have to return vertex. If I return vertex, then this will fail too. I know it will, because there'll be issues where an index isn't even, doesn't even exist. Yeah, right, 220 with none. Maybe if I just made one up? If I put like 0 here or something? That time I guess it worked, but it didn't render anything, which I guess would make sense. Did I put neighbors at 0 at 1? So I just take that index. Then I get the broken thing from before. Yeah, I don't know. I don't think I can make this work, unfortunately. At least not this way. I wonder why this would only happen in shapes that have holes. Why would that be the case? Could this thing be starting over when it encounters a hole? Something like that? Hmm. I'm gonna go back to how it was before this way. This is with triangulation, I assume. Turn off that triangulation. That's what it's supposed to look like. And the reason it won't do that with triangulation is that there'll be vertices whose indices don't match the indices of the points in the object. I wonder if this point should be set to like... If the proper way to do this is to like give this vertex a new index, then return it with that new index? Would that make sense? Because what might be happening is it's creating a new vertex 220, which is functionally the same as this one, but it needs a new index. Although that wouldn't really make, or would it? Then what would be happening here? It'd be creating another index, which is a linear combination of these. Graphics indeed. Speaking of how frustrating this is, this software was written in the 90s. This is very old magic. It seems like this. Creating a new vertex out of these vertices. The thing is, this isn't even a vertex. There is no -1, 1, 0, comma 11. Is there? If I just print all the vertices, print V, and then I think I'll just put V. Oh my god, there is a -1, 1, 0, comma 11. Then how is this a -2, 2, 0, comma 11? There are two things. Oh my gosh. There are two vertices with index 11. So that never made any sense. Wait, how is that? Because the index is restarting for each contour. So what I have to do is put index equals 0 here for point and enumerate whatever. This should be index. I should put that there, then increment that here. I don't know what I expected to happen there. What was I supposed to be? What was I even solving? Wait, did it work here? Because there it worked. And I literally... Wait, it didn't change pretty much anything. Oh, this isn't enumerate anymore. And good Gecko, thanks for the follow. Okay, so now this... Now the indices aren't repeated, it works in whichever mode this is, with no triangulation. If I switch to using triangulation, then it also works. Okay, so that fixed it. That was fun. Only not really. Kind of terrible. Yeah. 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 That was a lot of hunting, too. What was I even doing before? Okay, so now I don't want to do this mobject. I want to use the mobject that was passed in. And for... so something like a T, this already worked beforehand. Oh. This worked beforehand because there are no holes or anything. That's a lot of printing. But now I should be able to do an O shape. Which I can. And hopefully an I shape. Great. Okay, so I managed to do it with triangulation now. That's great. And get rid of all this printing. Does this make sense, though? Oh, I'll see you, Angry Gecko. Thanks for watching. This combined callback, I think this is as good as I can do with this. Because in order to be able to use a triangulation, each vertex needs to have an index. And when it's combining, which creates a new vertex, that new vertex won't have an index. And that occurs when the curve crosses itself. However, the shaders that currently exist use a triangulation. They use indices. Which means the existing shaders would fail in this case too. So it should be safe. Okay. Wait, what is printing? Great, that's really fast again. Even though it's triangulating on each frame. Okay, now what I want to do... well, actually, I should probably clean it up some. But then... I want to hopefully be able to, add in the texture coordinates or whatever to make it curve. To do this trick. Hopefully. Yeah, this is fine so far. There's an MGL that you can rotate the full 360 degrees around all the scene, but on this thing stops on the halfway point. You mean like basically this where it stops? Yeah, that's intentional. It might be possible. I think literally all of it, all of that logic is in mouse drag orbit controls. The Manim GL way. Well, that is too bad. Just kidding. I think this should be doable. I think it might be literally these two variables, which aren't configurable. Yeah. Wait. Why would it go all the way around? I think those two numbers are limits on how far you can go. No, I don't know. Pi and negative pi. If I made this 2 pi over 3. Okay, then it doesn't let me go all the way around. I thought it was weird that if you put this on pi and negative pi, it doesn't actually stop you at pi and negative pi. You can just go around forever. But anyway, that's where you can change that. One day that might be a flag, but adding flags is annoying, so. So you have to change the code. That's literally why that's not a flag, by the way. Because adding flags is just, or it could be a config variable, I guess. Although those are annoying too. Okay. So I'm gonna try to clean this up. Actually, let me do this one more time. Okay, so that's great. So now I want to add those texture coordinates, and for that I want to actually print out these indices. So I want to split them. Reshape indices into one. There'd be groups of 3, right? Can I do -1 by 3? Wait, what? Okay, so this is printing each triangle. Damn, and it looks like what I was planning is that maybe you could tell which ones are need to be curved by taking 3 consecutive numbers. But I don't know if this actually has... This is actually doing a triangulation where there's 3 consecutive numbers reliably. So that's annoying. I wonder if there's a way to force that or something? Triangulate the interior of the closed path and form a triangle for each quadratic Bezier curve. After triangulation, have interior triangles shown in green and boundary triangles that contain curves shown in red and blue. I think what I'm gonna want to do is just take off some of the indices and see how it's being triangulated. So maybe I can do something like... I'll just put something equals 0 here. So it's like indices up to not including like 3 times val? Or negative 3 times val? Then I want a breakpoint at the end. Oh my gosh, give me a break. What did it do? Okay, so this works. Indices... negative 3 times val? Well, that didn't do what I thought I would do. Isn't val 0? Does negative 0 do that? Okay. So I don't want to do that. I just set val to 1, I guess. So that's good. There's a triangle there. Val isn't increasing. That val plus equals 1. Oh my gosh, give me a break. Better? Okay. There. That's okay. Oh yeah, that's a problem. Damn. This isn't triangulated according to the Bezier curves or whatever. Some of them are split. So basically it isn't triangulated like this for all the Bezier curves. How did Grant do this? I guess I could just literally copy paste what Grant did and just take out the triangulation algorithm. But I don't like what Grant did. Whoa, performance. Okay, so the way... Okay, Grant did this. How long Grant spent making the shaders? Well, he started looking to OpenGL like several years before we did. So there's a good chance it took a few From like start to end, it might have taken a few years. Figure out how to triangulate the interior to know how to send the points as to the vertex shader. First triangles come directly from the points. Indices equals numpy.a range. B0, B1, B2. V01s and V12s. Crosses. Convexities. Inner-vert indices. Sort the inner-vert indices. Rings. And then you triangulate. The points indexed at the inner-vert indices. Inner triangle indices. Those inner-vert indices indexed at a triangulation. Then the triangle indices are a stack of the indices and the inner triangle indices. That makes very little sense. Inner-vert indices. Sort the inner-vert indices. What is rings? A range 1 to the length of inner-vert indices plus 1. Indexed at this mod 3 equals 2. Okay, here's what I think is happening. If I can move all this stuff. What I think is happening is that if you have a shape composed of Bezier curves like a circle, and say this is made out of Bezier curves like this, like these are the start and end points, and these are the control points. Then these are triangles. These are the triangles here. But when you draw on the Bezier curves, it'll form a circle. And what's happening is you'll want to triangulate this, the interior, separately. Triangulate this, the interior, separately from these triangles, which are the boundary or something? Boundary. And in fact, I don't even know if you have to triangulate the boundary. They're already triangles. Each of these points, that's like, this is like P0, P1, P2. This is just a list of, well, it's also P3, P4, P5. These are already triangulated. And so, at the very end of this, the triangulation is a stack of the inner triangle indices, for which he needed a triangulation algorithm and indices Which, what is indices? And indices is just indexing along the curve. So there is no triangulation there. So only the interior is triangulated. So all of this to find finding inner verts. All of this to get inner vert indices, and then get inner verts, and then triangulate inner verts. This is to isolate the points that that aren't on the outside, I guess. Wait, is that hard? Because like this is all of the start points. This is all the control points. I'll just put start points. Also, I have to capitalize these. I just have to. And these are the end points. What is this? B1 final minus initial. This is pointing to the... This is like start arrow to control. It's this vector. And this is control to end these vectors. And it's crossing these vectors. And then getting a sign of the cross. Why? Well, I guess it says convexities right there. Is getting the concave parts that difficult? Concave parts. I don't get it. When you cross V01 and V02, what does the sign of a cross product mean? When the angle between two vectors is between 180 and 360, then a cross product becomes negative. Okay. I don't get it. I mean, it's obviously finding the convexity, though I'm not totally sure why you'd need that. And then the inner vertex indices. It's taking all of the start points. It looks like it's taking the end points that end a contour. Then it's only taking the control points if it's concave. It must be something like... Let me try to put this where all of it is actually displayed. Yeah, something like that. But this is a curve. That's not a curve. This control point, this is what he calls B0, B1, B2. And this is V01 and V12. And it's taking V01, all of them, and crossing with V12. So I guess concave parts as if this is negative. So I'm doing my right-hand rule here. And I guess this is going into the paper. So V01 cross V12 looks like that. But if I had something like this, would that change that? And I guess it, wait. Okay, here, this is going into the page. If this is V01, and this is V12, this is coming out of the page. If you were drawing a shape like this, if all this came together to make a shape, I guess you'd want to, if this is just a straight line and this is a straight line, you would want to shade this part of this one, the bottom. And I actually want to shade the bottom of this one too. So I guess that's not it. Okay. I thought that might have been it. Basically, concave parts has to exclude the triangles that are on the boundary. Why doesn't he just not take any of the control points? Why? If he could do something like for the circle. All of the points would be like this. If you just take out all the control points, then you get this, which is what you want to triangulate. So why is he keeping... He's keeping those if it's concave. If it's concave. So something like... This is concave. Let me do something easier. So here, darn. This, and just make that a Bezier curve. And the control points, this one, this one, this one, this one. So now, okay, so here the control points, these control points lie on the shape. This control point lies inside the shape. Although even if this was the other way, it was here, I would still want to exclude it. I'm so confused why it needs these concave parts. Somebody DM Grant. I think he might have actually explained this to me in more detail before. I think. Did he ever give you some rundown of the philosophy? Yeah, he did. I would show it on the screen, except one, it'd be kind of weird to show like text messages. That'd be sort of weird. And then two, how would you stream a phone? It'd be so hard. Okay. Okay, so he drew this example for me before. This, and then like this. Now here, it's actually curved too much, but I could pretend the control points are like this, 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 this. And the question is, which part of this would you want to triangulate? And the answer is that you want to triangulate this. Which means you do want to include some of the control points. And you want to exclude some of the other ones. Then once this part is shaded, yeah, that's when you add the quadratic Bezier parts. Here, these ones. So it must be, I think it has a Control C, Control V, all of it. Yeah, well, sort of. The ecosystem is behind Grant's showed in the Manim CE code. It's been diverging for a while. Although a lot of the OpenGL infrastructure is pretty similar. But other than that, Grant has some not that great code. And so if we can help it, wouldn't want to do that. It's weird to me that all you need to do to tell what's convex and what isn't is cross these vectors. Because if I cross this vector and that vector, this is coming out. And I guess it continues around. Then if I cross this vector and this vector, that's also coming out. But if I cross this vector and this vector, it goes in. And this one too. Let me remove that cross, it's confusing me. Why is that true? It could only be because this is oriented, right? Or this is that these go in a single direction all the way around. But if this was going the other way, would it still happen? If it's going this way, then that way. Now this is going in. So I wonder if all quadratic Bezier curves in Manim are oriented the same way? If so, I didn't know that. Start points, control points, end points. Okay, so I guess I cross all of those. That makes sense. Take the sign. That kind of makes sense. This is for trying to stitch together. This is for doing the holes and stuff. Which, do I need to do that? I think I might. I mean, the triangulation library will do holes for me. I basically just have to remove these triangles, these outside ones, and these triangles, in this case I want to remove the control point, and in this case I want to add the control point. Yeah. So I do want to know if it's concave, I guess. Concave or convex. Maybe I could try just... Maybe I will end up copying at least this. You have to sort these two? Okay. Let's see. Sort of triangulate my object here. Currently, every subpath, I'm just putting in all of them. Every single one. What I guess I have to do is, for each subpath, if the curve is part of a convex part of the Bezier curve, then exclude the control path, or the control point. And if it's part of a concave part, include the control point. Is that all there is to it? Also, how can you tell if this is concave or not? Oh, these have to go in different directions. They have to. I have to rely on them going in different directions. Okay, so let's see. So I have the subpath here. I guess then I could do this. No, this should just be subpath. Then I could get these vectors. Then I could cross them. And then I can get the convexities. Cos 2D is a custom function too. I wonder if there's no NumPy way to do that. I feel like there should be. V01s. V12s. Wait, why are there 4 of them? What shape is this? Oh, it's that shape. Okay, that makes sense. How does I know numpy cross? Array, another array, axis A, and axis B. B01s, B12s. Did that just cross them all? I don't know how to compute a cross product. Don't you like draw out a matrix or something? Oh, these are the sign. Negative 43. Jesus Christ. No wonder I don't know how to compute a cross product. I mean, if it's also this, then that's fine too. Wait, no, it's not. Oh, unit vector perpendicular to the plane. Okay. Well, if I were to switch this, if I were to do this, what was it? There was V01 and V12, V21, V12 and 01. This does switch whether it's coming in or out of the plane. Which I guess is all I need. What is np.sign of that? Interesting. Anyway, I'm gonna use np.cross. Then convexities. Crosses at all rows, column 2. Okay, so now if I print the convexities, one is 0. Is that okay? Oh, it's still taking off triangles. I feel like that didn't do what I was supposed to do. But let's not take off part of the vertices. Don't need to do that anymore. See, a lot of this stuff I don't need anymore. I don't even want to break here anymore. Oh. Okay. So now I'm crossing all of these. How many crosses should I have? There should be one of these crosses for each curve. One for each curve. Oh, this is still on the screen. I didn't remember that. Don't need that anymore. One for each curve. And the outside of this was four. Four of them. So am I getting that many? Oh, man. Go here. Now, print V01s, V02s, V12s, and look at crosses. There should be four convexities. Itties. Oh my gosh, just printed. Why is there only two? This is doing something. Wait. Crosses here. The sign of crosses. Oh, I did this wrong. I meant to do that. All rows, column 2. I take that sign. Now there are 4 convexities. Okay. And it makes sense that there'd be one with 0 convexities because this shape has a few straight lines. And these straight lines will have 0 convexity. But I don't think the orientation of the inside part is opposite the orientation of the outside. Is left up, then it's going up, right, right down, left up. So the outside is clockwise. And the inside is also clockwise. So this couldn't work. I guess I could just reverse it. So left up, left down, right up, left up, like this. But now I have those convexities. And so the points that I want to... Why do these have to be sorted? Indices, A range. Invert indices, all of the start points. Only taking the control points if they're part of a concave triangle. And then only taking the endpoints if only taking the endpoints if it's indexing the end of a loop. Yeah, I guess that makes sense. It's that you don't double count the endpoints, since the endpoint is the same as the start point of another one. Of the next curve. Do I care about that though? I think I don't. guess I could just, since I'm doing for subpath and subpaths, I can just only include the last one. Okay. Concave parts is where convexity is less than 0. What? Is this a logical index? It must be. Then can't I do numpy.where? Fuck. Or a condition. Numpy.where whatever is less than whatever. Yes, and 5a and 10 times a. Wait, what in the world? A less than 5. 0, 1, 2, 3, 4. And then a. And then 10 times a? Well, don't know what that means. Return elements chosen from X or Y depending on condition. So a less than 5 is a condition. Oh, this is a condition. This is the array, and this is what it... No, I don't know. It's like concatenating two of them. Elements chosen from X or Y depending on condition. Oh. This is the condition. Then if it's less than 5, it'll return A. If it's not less than 5, it'll return 10 times A. That is a super random seeming function. Okay, now I'm just gonna do what Brad did. Gotta steal that code. Okay. Indices. Man. Can't even use that variable anymore. And shouldn't this be... Yeah, this is introvert indices. I'll do something like all indices. Which is this A range. This will be the length of the subpath. D-type end, yeah. Or all indices. So I take all the start points, take the end points if it's concave, or the control points if it's concave. What about the ends? Why don't I just only take the last one? Why isn't it just this? Because I'm already splitting by subpaths with mob.get subpaths. I wonder how well this will generalize to multiple mobjects. Is that worth thinking about right now? Probably not. Yeah, probably not, to be honest. Okay, now I have the introvert indices, then do this. then I'll do the point and inner verts and triangulate that way. Oh, I have to sort it too? No, because it's just H stacked. Okay, so sort that, do that. Don't know what rings is. Oh, this must be the holes. But I have the inner vertices now, and so I guess I'm supposed to triangulate this instead. But I have zero faith that that will work. So I just want to make sure it's working right now. Okay. I put the odds that this works at basically 0. Okay, that did much better than I expected. Although it's still doing weird stuff. Yeah. It's like including this midpoint. Wait, this shouldn't even be a vertex. Why is this here? 0 not equal 0. Oh, did I mess that up? Do I want to include it if it's 0? I'll put an eagle here. Wait, it already doesn't like that. Where it's equals convexity is less than... Can I do like this? That couldn't... Doesn't this mess with Manim's or Python's syntax? Okay, that just like... Yeah. I don't even know if I drew straight lines with this. Oh no, I did. But I did it on the inside. So if I take this out. That's weird. Okay. I have no idea what this triangulation is doing right now. Since I copied it right now. And I think debugging this is going to be a little bit of a nightmare. So I'm going to put it off until tomorrow. And raid zone with my two viewers right now. Great, this person just started. Okay. This way I can not have to figure this out until tomorrow at least. See you.
When you feel it, you'll know that every good story is a love story. And this is ours.